Hello students, we are back at it again. Okay, the last time we talked about a graphical application of calculus whereby we were touching on tangents, isn't it? We then looked at some questions, right? Some pretty hectic questions that were asking us about equation of a tangent to a graph, isn't it? Now, as always, I'm gonna start with reminding us of this crucial notation. Remember that if you have f of 2 is equal to 7 and then f prime of 2 is equal to 7, these things do not mean the same thing, right? The one on the top means if my x is 2, right? If my x is 2, the y value is what? Is 7. Okay, what about this one? This means at a point which is a point that is having an x coordinate of 2 and then I do not know the y value, the gradient at that point, right? The gradient at that point is 7. So remember, if I were to have my function maybe like this, let's say this is our function here, and then here it's our x value, right? Let's say the x value is here and the x value, the x is 2 and then I do not know y. The gradient of a tangent line there, if I were to put a tangent line there, right? Let's try that again. Let's say I put a tangent line there, right? The gradient of this tangent line there, right, would be how much? Would be 7. Okay, the gradient would be 7. That is what this one means. Okay, it says the gradient at this point where x is 2 is 7, or you can say the gradient of a tangent line passing through this point is what? Is 7. Okay, now let's look at a problem here, right? It says given that f is that, determine the equation of the tangent to f at x is equals to 5. I know that I crossed out this part. We're gonna look at it afterwards. Now the question right now says, what is the equation of the tangent to f at this point? Okay, remember, giving you that at x is equals to 5 should remind you that we are talking about this point where the x coordinate is 5. By the way, what is the y coordinate at that point? Right, let's maybe start there. So since we know that already our x is 5, right, to get the y value, right, to get the y value, we're gonna say f of 5 is equal to 5 squared minus 2 into 5, right? And then now that will be 25 minus 10, which is 15, right? So f of 5 is 15. Remember, what is f of 5? It means x is 5 and then the y value is what? Is 15, right? So that is okay. Now we got our x value and then we got our what? Our y value. Now what is the next step? We do know that there is a tangent there, right? They said equation of a tangent. Now let's remember, what is a tangent, right? A tangent is if when we have a graph, right? When we have a graph, a tangent is just a line that touches the graph at only one point, okay? That is what we call a tangent. It's a line that touches the graph at only one point. Now that tangent there, right? This tangent here, it's touching the graph at which point? This point here, whereby x is 5 and then y is 15. Okay, this is our tangent there. So remember, our tangent is a straight line. How do we get the equation of a straight line? To get the equation of a straight line, that's why we call it the equation of a tangent, because our tangent is a straight line. So to get its equation, we're gonna say y is equal to mx plus c. But now the question becomes, what is the gradient of our tangent line? How can I get the gradient of this tangent line? Should I use this formula, m is equals to y2 minus y1 all over x2 minus x1, while I have one point only on the tangent? No, I only know one point on the tangent, so it means I have to find the derivative of f so that I can get the gradient of the tangent. Okay, so that is why we say to get the gradient of the tangent, right, m of tangent, you're gonna find the derivative of f, right, the derivative of f at 5, meaning the gradient of f at 5. Okay, so this is what we have. So first of all, let's do it step by step. Let's start by finding the derivative of f. Now the derivative of f at x, since our f at x is x squared minus 2, you're just gonna say it is 1 times 2 there, right? And then you're gonna get 2, and then you have x, right? So it's 2x and then minus 2, because here the exponent is 1. Remember, you can go to our previous videos to better understand that, right? Now, where do we want the gradient? We want the gradient at x is equal to 5. So we have to find the gradient at 5, right? That would be 2 into 5 minus 2, which means 10 minus 2, which means 8. So it tells you that the gradient here would be equal to 8. Okay, the gradient of the tangent is equal to what? 8. Once you get the gradient of the tangent, it means you can substitute it into the formula there. Okay, so we go further to get the equation of the tangent, because they said determine the equation of the tangent. So now we then say, therefore we have y is equal to 8x plus c. Now how do we get c? Remember, you're going to substitute your point here. This point, you're going to substitute it. So where you see x, you put 5. Where you see y, you put 15. You have 15 and then 8 into 5 and then plus c, right? So that you have your 15 is equal to 40, if I'm not mistaken, is equal to c. Therefore you will have c as 15 minus 40, which will mean that what answer is negative 35. Negative 25, right? Yes, that will be negative 25. So therefore the equation of the tangent will be what? Would be y is equal to 8x minus 25. That is the equation there. Okay, so that is the general procedure, good people. Whenever they want the equation of a tangent to f at a certain point, and that point is this one, they want to know what is the equation of this tangent. So it means the equation of this tangent here, this line, it has the equation of y is equal to 8x minus 25. That is a tangent line. Okay, now let's elevate this a bit, right? Now let's remove what they want there, right? Now they say to you, determine the equation of the tangent. Still, we are looking for the equation of the tangent, isn't it? We are still looking for the equation of the tangent. So since a tangent line is a straight line, we are just looking for this y is equals to mx plus c, right, to f, which is parallel to this line. So the equation of that tangent must be parallel to this line. What do they mean when they say this tangent? Remember, this would be our tangent, right? They are saying that our tangent, it must be parallel, right? It must be parallel to the line. It must be parallel to the line x plus y is equal to 7. How can our tangent be parallel to this line? Well, first of all, let's write the equation of this line well, okay? So the equation of this line will be y is equals to negative x plus 7. We always need to make y the subject of the formula. So we got two lines. This is a straight line, okay? This is a straight line. And then our tangent is also a what? Our tangent is also a straight line, right? Now, they are saying that what is the equation of the tangent? This tangent which is parallel to this line here that has this equation. How can that be possible? good people, I need you to know that two straight lines, they are only parallel if they have the same gradient. Remember that? So it means the gradient of our tangent must be equal to the gradient of the line, so that both of them are parallel to each other. So we must find that the gradient of the tangent must be equal to the gradient of the line. So what does that tell us? Right? What does that tell us? Here, don't we know the gradient of this line? Yes, they already gave us here, okay? This is the gradient of that line. The gradient of the line is equal to -1 because the equation is y is equal to mx plus c. So your m here is -1. So we already know the gradient of the line, and that gradient must be the same as the gradient of the tangent so that the lines are parallel. So this tells us that therefore the gradient of our tangent must also be equal to what? To -1, which is the gradient of the line. So now that we have this, we can substitute it there into our formula there to say therefore, right? To say therefore our equation of the tangent must be y is equal to -x plus c. Now we're just left with finding c. So when they tell you that the equation of that tangent must be parallel to the line, they're already telling you that they must have the same gradient. And since here the gradient is -1, it means our tangent must also have a gradient of -1. So we have it here. Now the only thing we're left with finding is c. Now, how will we get c, right? Think about it. Let me give you a minute to think about it. How will we find c? We need to substitute a point, right? Now, how will we get the point? We don't know if the x value at that point, we don't even know the y value at that point. We only know that since this is a tangent, our graph, if it's like this, right? If our graph is like this, it means our tangent is passing through somewhere there. That is our tangent there, right? We only know that the gradient of this tangent is -1, but we do not know at what point is the tangent passing. How can I get the point at which the tangent is passing so that I can substitute that point into the equation, then I get the answer? Right. Remember, you are given the gradient of a tangent which is -1. That is the same as saying that if I were to find the derivative of f, right, I would get the answer as -1. I would get the gradient as -1. But the question is, it's at what x value? At what x value will I get the gradient to be -1? And can you remember, if we have f derivative of 3 and then maybe it's equals to 5, it means the gradient of our tangent is 5 at a point whereby the x is 3 and then we do not know the y. Isn't it? The gradient is 5 at x is 3. But here we know that the gradient is -1 of our tangent. It's -1, but we don't know at which x value is that. So what does it mean? We need to find the derivative of f. Then we can solve for that x value. Okay? We need to find the derivative of f, then we can solve for that x value. So now let's find the derivative at f and then solve for that x value. So we know that f at x, I'm just gonna write it here. Our f at x is equal to let's see, is it 2x squared? It's x squared minus 2x, right? So it's x squared minus 2x. So the derivative of f is 2x minus 2 is equals to -1. Now I can solve for that x value by just saying 2x will be -1 plus 2. I took this to that side, it changes the sign, so 2x would be equal to 1. When I divide by 2 both sides, I get that x is equal to half. So what does this mean? It means at this point, half and then a certain y value, the gradient of the tangent is equal to what? To -1. Okay? So it means therefore f prime half is equal to -1. The gradient at x is equals to half. At a point where x is half, the gradient is -1. Okay, and you can check. You can substitute half here. You will see that the gradient is -1. Okay, so now that we have x, now we're left with finding what? Y. How do we get y? Remember, to get the corresponding y value, you're gonna substitute that half in here so that you get the y value. So you're gonna say half and then squared minus 2 into half, right? Then you're gonna get 1/4 minus 1 there, right? So 1/4 minus 1 is the same as saying 1/4 minus 4/4. It's -3/4. Okay, so it tells you that f of half is what? Is -3/4, which means when x is half, the y value is -3/4. So do you see that this and this, they don't mean the same thing? This means when it has a prime, it means the gradient is -1. The gradient of a tangent is -1 at this x value, or the gradient is -1 at that x value. While here it means the y value is -3/4 at that x value. I hope that sinks in. So now that we have x and then we have y, so what do? We substitute now in here, right? We substitute in there. So therefore we then say therefore, since y is equals to -x plus c, where I see y, I put -3/4. Where I see x, I'm gonna put half, right? So I have half and then plus c. Then I have -3/4 plus half as my c. Therefore, our c will be let's see. This is times 2. This is 4 times 2. We have 2. So -3 plus 2, right, plus 2 is -1. So we have -1/4. All right, so therefore the equation of the tangent, right, the equation of the tangent should be, right, should be y is equal to -x minus 1/4. All right, great. Quite a lot, but the idea there is just to understand that when they say determine the equation of a tangent, we want y is equal to mx plus c, because a tangent is a straight line. Now they're saying that that tangent must be parallel to this line. Well, if a tangent is parallel to this line, which is also a straight line, they must have the same gradient. So since here they gave us already the gradient is -1, therefore we know that the gradient of the tangent must also be -1. So it means now we have -1 into the equation. We just need to find c, and to get c we need to substitute x and y. How do we substitute x and y when we don't even know any point, or this point at which the tangent is passing? We solve. We say we know that the gradient is -1 on the derivative of f. We know that the gradient is -1 of the tangent. At what x value is that happening? So you find the derivative of f first, then you solve for the x value at which the gradient is -1. You are solving for the x value for which the gradient is -1. So once you got that x value for which the gradient is -1, therefore you now know that here let me just remove that. So now you know that here you have half and then y. It means the gradient is -1 at a point where x is half, but you do not know the y value. So to get the y value, you substitute into the original equation of f, then you get the y value. Then now that you know the y value, you substitute into this equation here, right? You substitute into that equation, you get c. Then you got the equation of the tangent. I hope that is clear, right? I hope that is clear. Now we move to the next one. So for the next one, it says, this is what we have here, right? It says, if you are given f at x, right, if we're given f at x as 3x minus 2 all squared, right? And you are given that f prime of p is 6. What does this mean? It means the gradient of the tangent is what? Is 6 at x is equals to what? At x is equals to p, right? So it means you only know that if you have a point, right? If you had a point here, the point will have an x value of p. You do not know the y value, but then the gradient of a tangent there, the gradient of the tangent would be what? Would be 6. It's always helpful to sketch this, okay, so that to make sense of the question. Now it says determine the values of p and q if the tangent meets f at the point p and q. Oh, so it means there, instead of writing y, we should write what? We should write q, right? We do not know p and then we don't know q. How would we get p and q? That is exactly the same question we did before. Remember, we had a tangent passing through a point and we had x and y. We didn't know what was x, we didn't know what was y. We only knew the gradient of the tangent. How did we find the x value? Yes, you find the derivative of f, and then after that you equate that derivative to 6. Then you want to know at what x value do I have the gradient as 6? At what x value do we have the gradient as 6? At what x value do we have the gradient of the tangent to be 6? So what does it mean? You need to first find the derivative of f. Then you equate it to 6. So how do we get the derivative of f? First of all, we need to simplify f, isn't it? So what I'm going to do is that I'm going to take this down here, and then I'm going to simplify f first. So our f at x will be 3x minus 2 multiplied by 3x minus 2. Then we say 3 times 3 is 9, x times x is x squared, 3 times negative 2 is negative 6, and then there's x. Negative 2 times 3 is negative 6, and then there's x. Negative 2 times negative 2 is 4. So I'm going to have 9x squared minus 12x plus 4 as my what? As my f at x. Now what is left is find the derivative. So the derivative of f would be 9 times 2, which is 18, and then you say 2 minus 1, which is 1. Okay, then here the exponent is 1, so you just take the number in front. Then the derivative of a constant is what? Is 0. So the derivative is just 18x minus 2, 12. Now that you know that this is a derivative of f, what is a derivative? It's an equation to find the gradient at any point. Okay, so now that you know this is the derivative, you know that the gradient, right? It says the derivative of x is 6. You know that the gradient is 6, but you do not know at what x value that is happening. So you want to find out what x value is that happening. So you take 12 to that side, you're going to have 6 plus 12 is equals to 18x, right? Then after that, what will you have? You will then have 18, right, is equal to 18x. Then you divide by 18 both sides, therefore your x is 1. What does it mean? It means all of that is happening here, where x is what? Where x is 1. So it means the derivative at 1 is equal to 6. The gradient of the tangent at x is equal to 1 is 6. Alright, now you need to know the y value. How do you get the y value? That's easy. You go to the original equation and then you substitute x to get the y value. So you're going to say f of 1 will be, you substitute 1 where you see x, 3 into 1 minus 2 all squared. So that will be 3 minus 2 is what? Is 1 squared. And then you get the answer as 1. Okay, so the answer here, it means q, right? It means q is what? Q is 1. Because what does this one here mean? It means when x is 1, y is 1. What does this one here mean? It means the gradient of the tangent is 6 when the x value is what? Is 1. Okay, I hope that makes sense, good people. That's where your 4 marks would go there. All right, that's where the 4 marks would go. So we now know that P is 1 and then Q is also 1. Right, now let's do another one. Right, remember, the more questions we do, the more we get comfortable at answering these questions then. Now look at this here, right? But this one now is now a bit different. It's now, but the procedure is still the same. Okay, so we're gonna try and do it fast. The equation with this, the curve with this equation passes through the point A, 2 and B. Determine the equation of the line perpendicular to the tangent to the curve at A. It's a lot. I don't wanna lie. It's a lot. Equation of a line perpendicular to the tangent to the curve at A. Seems confusing, but good people, it's really nothing. Eh? It's really nothing. Now, let's make sense of what we have. We have a curve, first of all. This curve here, what type of graph do we have here? Well, we don't even need to know what type of graph that is, but we know that if we can just assume that maybe that graph looks like this, what we know is that at a certain point we're gonna have a tangent line, isn't it? We're gonna have a tangent line, and a tangent line passes the graph at only one point. So the gradient of this tangent, right? The gradient of the tangent, we do not know it, right? But it passes through this point. Which point is that? It's A. That point A, the x value is 2, and then we do not know the y value, right? Now check, I already know that the x value here is 2. I can get the gradient at 2 by finding the derivative at 2. Then I got the gradient of the tangent, isn't it? So it means if I can find the derivative of this thing, then substitute 2, then I'll get the gradient of the tangent, isn't it? So let's do that. So the gradient of, okay, we have first of all we have y is equals to x plus 12 over x. Now remember, to find the derivative here, you need it to be in the form of ax to the power n. So what are we gonna say? We're gonna say y is equals to x plus 12 times x to the power negative 1. If you can check our videos on applying the differentiation rules, then you'll remember this. And also you would remember that to find the gradient here, or the derivative, I say dy over dx, because we are talking about x. Then I say for this one, the exponent is 1, so I'm just going to take the number in front, the coefficient, which is 1, and then here I'm going to say 12 multiplied by negative 1, and then I say x negative 1 minus 2. So it tells me that dy over dx is what? Is 1 minus 12x to the power of negative 3. This is dy over dx. This is the derivative. Okay, this is what? This is the derivative. If I can write this thing in terms of saying f at x, and then I say x plus 12 over x, it means the derivative of f would be 1 minus 12x to the power negative 3. This and that are exactly the same thing. So I know that at x is equals to 2, I already know that we have x as 2, right? If I can substitute 2 into the equation, the answer that I'll get is the gradient at that point, or which is also the gradient of the tangent. So I can say f prime of 2 will be equal to 1 minus 12 into 2 to the power negative 3. Then I will get the answer for this. Put it in your calculator. So the answer is negative half, right? It's negative half. So it tells you that the derivative at 2 is negative half. It means the gradient of the tangent will be negative half at x is equals to 2. So it means here we already know that the gradient of the tangent is what? Is negative half. But good people, Why am I using this notation? It's so that it helps, it's like easy to visualize. Because here, if I were to use this instead of doing this, right, what would I say, right? We should get the same thing using this notation. So now that you have the derivative, you would say at x is equal to 2, the derivative, which is dy over dx, right, the derivative would be equal to 1 minus 12 into 2 to the power negative 3. You'd get that the derivative is what? The derivative is a negative half. Okay, so it means the gradient of the tangent is negative half at x is equals to 2, or the gradient at that point is negative half at x is equals to 2. Okay, so that is the gradient of the tangent. Now we do not know b. B is not something that is difficult. We can quickly find b, isn't it? Now we know the derivative and then we know the gradient. Now we can quickly find b. So okay, I just erased the dy over dx. So to find b, remember you just substitute x as 2 into the original equation to get the y value. So y would be 2 plus 12 over 2. Okay, it's easy to do it with this one. 12 over 2 is 6, so the answer is 8. So therefore our b is what? Our b is 8 there. If you don't want to visualize it in this format, you can still say f at x is equals to x plus 12 over x. When you say f of 2, that would be 2 plus 12 over 2. You get the answer as what? As 8. So f of 2 is 8, which means when x is 2, the y value is 8, which is the same thing here. When x is 2, right, the y value is 8, right? The y value is 8. So these notations, let them not confuse you. It's the same thing. It's still the y value there. Okay. Now, that is it. But now I was just using the information given to get that gradient, to get the y value. I have not answered the question. The question said determine the equation of a line perpendicular to the tangent. So this is a tangent here. We can get the equation of the tangent. It's okay. We can get the equation of a tangent. And here we now have the point, and then we also have the gradient. So we can just go to the formula of y is equals to mx plus c and find the equation of a tangent, which is not needed, but I'm just doing it to remind ourselves, right? So equation of our tangent here, you can get it by saying y is equal to mx plus c. Then you then say the gradient is negative half, right? And then you substitute this point 2 and 8. You can just say 8 is equals to negative half into 2 and then plus c. Then you can say 8 is equals to negative 1 plus c, right? So 9 would be your c. So therefore the equation of the tangent is y is equals to negative half x plus 9. But that was not what the question asked us. The question said they want the equation of a line perpendicular to the tangent. So it means here we have a certain line here, and that line, right, okay, here's the line here. That line is actually perpendicular to the tangent, like this. It's perpendicular to the what? To the tangent. So this is the line here. So they want the equation of this line, not the equation of the tangent. They said determine or rather determine the equation of a line perpendicular to the tangent. So this is the line that is perpendicular to the tangent. Here you would be finding equation of a tangent. It's not needed. What is needed is the equation of this line. That line is a straight line. So the equation of the line, okay, the equation of the line would be y is equals to mx plus c. That will be the equation of the line. So the question is, what is the gradient of the line? And then what is the point that we substitute? Wait a minute, what would be the point that we would substitute that is on the line? the point would be this one, because they said that that line is perpendicular to the tangent to the curve at A. So it means this line will be sharing the same point as the tangent. So this point also is on the line. So I can also substitute y as 8 and then substitute x as what? X as 2 to get C, just like I did here. But when I did this one here, I already knew the gradient of the tangent. The question is, what is the gradient of the line? Well, it's easy. For perpendicular lines, right, let's remember from analytical geometry, ne? For perpendicular lines, right, let me write it here. Perpendicular lines, ne? The gradient of line 1 multiplied by the gradient of line 2 will give us -1. What do we mean? It means the gradient of the line here, when you multiply it by the gradient of the tangent, you should get -1. That is for perpendicular lines. So we are saying this because they said they must be perpendicular. So this is for perpendicular lines. For parallel, remember the gradient of the lines would be the same. Okay, so using this, now we can get the gradient of the line. So we can just say we do not know the gradient of the line, then we put multiply, but we know the gradient of the tangent. What is the gradient of the tangent? Is -1/2. So we say times by -1/2 is equal to -1. Then how do we get the gradient of the line? You divide both sides by -1/2. By what? By -1/2. Why? Because we have a multiply here, right? So a multiplication sign there. So therefore, the gradient of the line would be equal to -1 divided by half, which should be 2, right? Which should be 2. Therefore, now that we have the gradient of the line, we can substitute it there, right? So for the equation of the line, right? Maybe we should remove this part, right? So for the equation of our line, right, we know that y is equal to 2x plus c, because the gradient is 2, right? Then we just substitute the point there to say y is 8 and then x is 2, right, to get c. We're gonna say 8 and then 4 plus c. Let me say 8 minus 4 would be c, therefore our c would be 4. Therefore the equation of the line says y is equals to 2x plus 4. Alright, y is equals to 2x plus 4. Well, here I was not really accurate per se, because this tangent line, it is actually this side here. It is actually at this side, and then the line is actually like this, and then they are perpendicular like that, okay? But whichever side, what was very important is just to understand the concept, okay? To understand the concept of finding the gradient of the tangent, finding the corresponding y value, and then finding the equation of the line. Alright? Okay, so we'll continue with this on another video, whereby we look at more complex problems on this.